So that means you will be having 2 homework.
Yes, but it's the weekend, so...
So let us...
So you can't enjoy it.
Exactly.
I want to sleep for the rest of my life.
But don't worry, when you're dead you can sleep. But right now you have to work. Right. We are... Yeah, they're not... Okay, oops. Here we are. Right, so we have one more lesson on turning force, and then we'll move to something new.
we will finish mechanics
Before the break.
for the break.
Yeah. Yes, you have. Mechanics will be until the break. Now, this is the name of the lesson, but just so you know, I also sometimes call the lesson this, if you want the other name as well. I call it the force theorem. So you can call it this, but I usually call it this. Okay, so
This is easier. Yours
yes,
is easier.
yes.
So I will call it free force.
No, I would like you to write down both names.
Free force theorem.
Yeah, well, I'll switch to it in a moment when we start writing something.
What?
So did you write this one down?
Yes.
Yeah, okay. And the other name for it, which is a little easier, three-force theorem.
This is easier.
Oh, I know this. I know what's easy, trust me. Okay, got that? Now, so there's not a lot in this lesson. It's quite short. It's really about this theorem rule. There's a very special type of problem in turning forces, and what's special about these types of problems that we're looking at today is that there's exactly 3 forces on it. So here's an example of a ladder against a wall. Like you put a ladder up against the wall like this. You see what I mean? Yeah. So if you look, there's 3 forces. The first one is the weight, of course. The second one is the reaction from the wall. And then the last one is the reaction on the ground. Now, why is this one at an angle and not like this? Why is it this way and not straight?
It will fall down if it.
Yeah, if it was straight, then the ladder would move to the right because of this. You need some force going left so the ladder doesn't fall. Yeah. So this is at an angle. Now, when you look at those 3 forces and you draw them, what do you notice about them? Well, you should notice that the 3 forces, they all meet at one point. And this only happens when you have 3 of them. It's a special situation. So when there's 3 forces, you know that they all meet on the diagram in one point. And this is useful for calculating angles. Okay, so this is a special system. It's special because there's 3 forces acting on the system and the system's in equilibrium. So if it's balanced and you have 3 forces, then they all meet at one point. Okay? So the definition is when 3 forces act in the same plane on a mass in equilibrium, then all the lines meet at one common point. So this is like the definition, the idea. You can write this down. And also, after you write it down, I then would like you to draw this as an example underneath the definition. Do you need me to move the projector, or it's okay, you can still read it, yeah?
It's okay.
Okay, so if you've written that down, I want you then underneath to draw the ladder as well. You don't have to write all the names. I just want to see that the three of them meet at one point here. Okay. Something simple to draw. It doesn't have to be as much as this.
Write the words in the red.
I don't need them. I really just want the diagram.
Okay. Excuse me, can I go to the toilet?
Yes. Now, you see, you should have sat down here, because how are you going to get by there? Did you push that out? Yes. And you should have three forces, and yeah, they should all meet. Yeah. Okay. Yeah, because you're going to need to take it back out. Okay, continue with this. Yep. Now, I said let's see the proof, but I don't think I'll do the proof. It's actually a very simple proof, but it's not important because it's not on the exam for sure. So we won't bother with the proof for this one. So we'll go straight into doing an example of using this, okay? So you can write this down or you can draw it. A 10 kilogram ball of radius 5 centimeters hangs on a smooth wall by means of an 8 centimeter string. Do you remember what a string is? Good. So there's a ball and there's a string and it hangs on a wall. Do you think you can try and draw that? If you can't draw it, just write it down.
What's the radius?
Which word?
Follow radius.
Radius, yeah. Look, if you don't know, this is radius. That's radius. Radius 5. Yeah?
String is like a rope, yeah?
Does anyone think they can draw it? Do you know radius? He asked me. This is radius.
The point from the center of the circle to any.
To the circumference.
Yeah.
Yeah. Did you draw or write?
Everything.
Okay, good.
I was in a mood to write.
You wrote? Yes. Did anyone try to draw? Andy? You drew or wrote?
Drew.
Let's see what you drew. Not too bad,
Yeah.
but not perfect. Anyone else try to draw it? You're going to draw it? Are you going to draw or write?
I wrote it, that's fine.
Okay, do both, okay. Right, I'll draw it now. So, what is the radius? 5 centimeters. And where is it hanging? Hanging on a wall. Like this. And how is it hanging on the wall? With a
String.
string. So this is what you should have drawn.
Doesn't hand either.
Doesn't have to be vertical. Okay, are you happy with that picture? Yeah. Now, how many forces are on the ball?
Why, reaction to
How many forces?
The force by the wall and the.
How many?
3.
3. The first one,
weight.
Weight.
the weight. Did I give you the mass? No?
Yeah,
10
10
kg.
10. Okay. What else? The reaction from the wall, which is here, yeah. That's or. And what else?
No.
The rope, so that's T. Now this is where the theorem, the three-force theorem is useful, because you know that they all meet at the same point. So if I go dot, 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 it meets here, doesn't it? And this one meets here. Therefore, this one also must meet here in the middle. Now that's very useful because I can draw a triangle now. How big is this part of the triangle?
8 centimeters.
No.
12,
8 plus 5.
13.
So it's 13. How big is this part?
10.
No.
5.
5. And
5 is only half of.
yeah, but this is the triangle here.
Yes.
Ah. And from Pythagoras, this one will be
12.
12. So, can we know this angle?
Yes.
Yeah, so be carefully now. Tan inverse 12 over 5. What's that?
67.4.
67.4 degrees. Sorry, 67.4. Now think about this, Look at me, think about this. This is really interesting because I never told you where this was on the ball. You know, like it could be here, maybe it could be here. I never told you. But because there are three forces, you know exactly what angle this should make. So it doesn't matter that I didn't tell you where it is. It must be here. Guaranteed.
Because they must meet.
They must meet. So they must be there. So it's not here, it's not here, it must be here to go to the center. Okay, and I forget what I was asking you for. The T. Okay, so let's see. I want the T. So do I know this angle? Yes. So if I draw here in ugly green, this one will be T cos 67.4, and this one here will be T sine 67.4. And what must T sine 67.4 equal?
10G.
Yes, why?
Because different directions.
No. What's my thing I say in class?
No, they both are in the same. Going up.
Up force?
Equal
Equal
down.
direction.
Yeah, that's what he said.
Opposite direction.
Yeah, but say it the way I say it. You know. Right, so give me the T now. So we get the T. What's the T? You get the T?
I don't know what that is.
Why don't you have a calculator yet?
one-
You need to buy one.
106.53.
106.3 newtons.
Yeah.
Did you need to calculate turning force to do this one? No. Did I calculate turning force? No. So, if you calculate turning force, you will get the same answer. But by using my theorem of three forces, I could very quickly work out the angle without the need of doing anything else. In the exam, sometimes you get problems with three forces, and you can use this trick to do it quicker.
You are done?
I have to see.
No, I can't see that.
Yeah. Yeah. So, I'll just say, this trick that I'm showing you, okay, it's not actually on the syllabus, but I felt it was important to show you because sometimes in the exam they give you problems with three forces. And if you knew this result, you can do the question a lot quicker. If you know that three forces always meet at one point, then you can do problems like this much quicker. In the exam, they actually think the students should do this using turning force, which makes it much longer to do. And actually, it means that there's many marks for the question. But if you can do it this way, you can do it quickly, but still get all the marks. So it's like a shortcut, a quick way to do it. Not all the questions in the exam have three forces. If it has four forces, then no good. You can't use this. It needs to be three. But it's a good trick.
Is all of the three you can use it?
Yep. If there's three forces, you can use this trick. Yeah. Continue. Okay. So there was just the one example to give you the idea, and there's a couple of questions here. So I don't know if you want to take a picture or I don't know. Should I move this?
Oh, we're not doing it now?
No, I think I'll do the next lesson, and then if there's time at the end, you can start it. I probably need to plug this in too. Just a sec, guys. Yes. Oh, throw it.
Okay, plug it.
Before, yes.
Right on
Just
time.
in time.
Yes.
Good.
Or not.
Can I go to the bathroom, please?
Yes. But why did you wait until the exact moment I put this in?
I can.
No, you'll kill yourself. You'll kill yourself. Whatever. That's great. Great. So we'll have a look now at the next lesson. So I think what will happen is, because you have two homeworks, and these questions, I'd say next time we maybe only get one topic covered. So, did you want to, you took a picture if you wanted
no,
to?
I still.
Okay, quick.
But in Moodle.
It's also in Moodle.
Yeah.
They like, I don't know why, they like doing this. It's, I don't know.
Fun.
Yes. Yesterday, or maybe it was Wednesday, I went to the Vietnamese coffee shop. Do you know this coffee shop?
Yeah.
Oh, you go there?
No, but I know.
You know it. And I tried traditional Vietnamese coffee.
Where is?
It's near the school. If you go out the gate, turn right, and then at the bar, turn right again. You walk a little bit and you'll see it on the left. So I tried traditional Vietnamese coffee. Very sweet.
Yeah.
Very sweet. Yeah.
All the things in Vietnam is very sweet.
Very sweet in Vietnam?
Yeah. Even the popcorn. If you
Sweet
have
popcorn.
five
Yes, in Ireland we like salty popcorn.
Same here.
That's the best.
That's the
You like salty popcorn?
No, I have
But
caramel popcorn.
I know in I know in Korea you like sweet popcorn.
Sweet and
Yeah.
salty sauce.
Both is good, yeah.
In Vietnam,
Yeah,
only sweet
only
popcorn.
sweet.
Yeah.
Chocolate?
Sweet.
Yeah. And for you it's salty, the popcorn. Butter on top.
No, the salt like.
Oh, just salt.
Salt.
Just salt.
Just salt.
Ah.
I like caramel popcorn.
Caramel popcorn, nice.
Sweet,
Yeah.
sweet.
We mix it.
No.
Salt one, butter one, and cheese one.
Yes.
Yeah.
Wow.
I don't mix them though. I just eat them.
But you get the three of them.
Yes.
Okay.